Hi, this is Walter Stone, and this is Unit 6, Lesson 1. In Unit 6, we're learning about factoring polynomials and using the zero product property to help us solve some equations. So this first lesson is about factoring out the greatest common factor, and after finishing this lesson, you should be able to factor polynomials where the terms have a common factor and factor polynomials by grouping. So when factoring out the greatest common factor, we want to remember that factoring is the reverse of multiplication, and one technique to use when factoring a polynomial is to look for and factor out the greatest common factor. So we see in this first example that in 4y squared plus 8, 4 is a common factor to both 4 and 8. So 4 can be multiplied by y squared, and 4 can be multiplied by 2. And that common factor of 4 can be taken out front of the parentheses or factored out, and what we can write inside the parentheses is the values y squared plus 2. And we can check this multiplication or factoring by taking the 4 times a y squared plus 2 to get 4y squared, and 4 times 2 is 8. So we can check our factors by doing the distributive property and multiplying back. So we see that we've correctly taken out the largest common factor or the greatest common factor, and we're able to factor that binomial. So we want to use that same idea with these guided examples. So on your guided note sheet, please do these examples along with me, and then I'll ask you to try a few problems. So here in this example, I have 5x squared minus 20x cubed. And 5 is a common factor, and x cubed is a common factor. So what we can do is we can take out 5x cubed as the common factor. And 5x cubed has to be multiplied by x to get 5x to the fourth. And 5x cubed has to be multiplied by negative 4 so that we get negative 20x cubed. So if I multiply back, 5x to the fourth minus 20x to the fourth gives me the original polynomial back. In example 3, we have 15y to the eighth plus 12y to the fourth minus 27y cubed. And when I look at 15, 12, and 27, I see that 3 is a common factor. And when I look at y to the eighth, y to the fourth, and y cubed, I see that y cubed is a common factor. So what I'm going to do is I'm going to write 3y cubed as my common factor. And that's going to be multiplied by 5 to get the 15. Y to the third times y to the fifth will give us y to the eighth back. And then we'll have 3 times 4 is 12. I don't mean for the size to keep changing here. 3 times 4 is 12, and y cubed times y is y to the fourth. Then 3 times negative 9 is negative 27, and y cubed times 1 is y cubed. So let's check and see here. Now, 5y to the fifth plus 4y minus 9, there are no more common factors inside, and that's a way to tell that we have the greatest common factor. And so if we multiply back 3y cubed times 5y to the fifth, that's 15y to the eighth. That matches the first term. 3y cubed times 4y is 12y the fourth. That matches the second term. And 3y cubed times negative 9 is negative 27y cubed. That matches the third term. So we factored out, in each of these examples, we factored out the greatest common factor. So now try these 4 problems. I'm going to pause the video, let you have a chance to try these 4, and I will work on them as well. And then when we come back, we can check our answers. So in the first try this problem, we have a common factor of 3x. So we can write this as 3x times x minus 2. And in the second problem, I see that 4x cubed is a common factor, the greatest common factor. So 4x cubed is multiplied by x squared minus 2. In the third problem, we have p plus prt, and p is a common factor, and p times 1 gives us p back, plus r times t. If I take p times r times t, I get prt. And in the last problem, I see that 3y squared is a common factor, and that's multiplied by 3y squared to get 9y the fourth, so that should be a square, and minus 5y plus 1, because the 1 times 3y squared gives me the 3y squared back. Okay, so check your work and see if it matches with mine. And if you're great with the skill, then we're okay to go to the second objective of the lesson, which is about the working with some more of these, taking out the greatest common factor. In this case, we have x squared y and x cubed y. So we have more than one variable. So we have to look for the greatest common factor with the x's and the y's. So always we have to look at the coefficients. So when I look at 12 and 20, we have a common factor of 4. When I look at x squared and x cubed, there's a greatest common factor of x squared. And when I look at y and y, there's only one common factor of y. So I need to multiply 4x squared y times 3 to get the 12x squared y minus 5x in order to get the x cubed times y. And in guided example 5, we have that 2 is a common factor. When I look at the p factors, I see that p the fourth power is common. And when I look at the q factors, I see that q squared is common. So I need to multiply by 5p squared. Then I need to multiply by negative 2p q to get the p to the fifth, q to the third, and then I need to multiply by, I have a p to the fourth, I have a q squared, and I have a 2, so I need to multiply by q squared. So I just check and make sure that there are no common factors inside the parentheses, and I see that in each of these examples. So pause the video, try these problems, and check your work. Okay, so we're back. So in the first example, you probably saw that there was a 4p squared r as a common factor, and that's multiplied by 5p plus 3 in order to get us the 20p cubed r plus 12p squared r back. And then in the second example, we have 3x squared y as a common factor, and that's multiplied by 2 to get the 6x squared y, minus 7x y squared to get the negative 21 x cubed y cubed, plus y to get the 3x squared y squared. And there are no common factors left inside the parentheses. Okay? Well, great. I hope that's working, and we're ready to go to factoring by grouping. So sometimes a common factor is itself a binomial, or sometimes pairs of terms have a common factor which can be removed. So when we factor by grouping, in this example we have y squared plus 3y plus 4y plus 12, and we can take a look at grouping the first two terms together and the second two terms together. And from the first two terms we see that there's a common factor of y, and that gives us y times y plus 3. And in the second two terms we have a common factor of 4, and 4 is multiplied by y plus 3. So we see that y plus 3 is a common factor that's multiplied by y and by 4. So we have y plus 4 times y plus 3. So in our guided examples, I'm going to use that same procedure, and in example 7, I'm going to take a look at a common factor from the first two terms, the 4x squared minus 3x, and the second two terms, the 20x minus 15. And I see that I have an x that's a common factor from the first two terms, and I have to multiply by 4x minus 3 to get the 4x squared minus 3x back. And then I see that 5 is a common factor from the second two terms. So I can multiply that by 4x minus 3. And a lot of times in these problems, these binomial factors will show up as a common factor. So 4x minus 3 is a common factor, and that's multiplied by x plus 5. So if we FOIL this, we learned about foiling. 4x times x is 4x squared. So that's from the firsts. The outers give us plus 20x, and that's there. The inners give us negative 3x, that's there as a factor in the original polynomial, and we have minus 15. So if we FOIL, we get back to the original four terms. Now in the second example, I have a as a common factor, and that's multiplied by x squared plus y. And in the second two terms, I have minus b as a common factor, and that's multiplied by x squared plus y. So when I multiply back that minus b, I have minus b x squared minus by. So x squared plus y is a common factor, and it's multiplied by a minus b. So if we multiply back, we have ax squared minus bx squared, ay, and minus by, and all those terms are in the original polynomial. Okay, so try these three problems. Remember, you want to look at a common factor from the first two terms and the second two terms. So pause this video and try these problems, and then I'll come back and I'll help you check your work. Okay, so in problem 7 we have x as a common factor multiplied by x plus 5 from the first two terms. And in the second two terms we have 4 as a common factor, and that's multiplied by x plus 5. So we have x plus 5 multiplied by x plus 4. Once again, I apologize for the change in size. I don't mean to be doing that. In the second problem, we have y as a common factor multiplied by 5y plus 2. And in the second two terms, we have 2 as a common factor, and that's multiplied by 5y plus 2 again. So 5y plus 2 is a common factor, and that's multiplied by y plus 2. So we have 5y plus 2 times y plus 2. So we have 5y squared, we have a 10y, a 2y, and a 4 when I FOIL that out. In this last example, we have p multiplied by x plus y, and we have minus q multiplied by x plus y. And we can see that x plus y is a common factor, and it's multiplied by p minus q. Okay, so check that back out by FOILing and see that we get the same terms as from the beginning. So please take a look at practicing this skill. You'll have an assignment on my math lab that's related to this, and also there are some written exercises here that you can practice as well. And it's good to get acquainted with the different types of problems that are in these written exercises, and you can check your work there as well. Okay, so we'll see you in class.